Today we're taking a look at quadratic functions. So quadratic functions are of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. A is not allowed to equal 0. If it was, it would just be bx plus c, which would be a line. And all quadratic functions have a domain of all real numbers. So in negative infinity to infinity. So this form right here is called the standard form of a quadratic function, and we can actually get a lot of information from the standard form of quadratic information. So the first thing that we typically look at when we're trying to figure out how to graph a quadratic function is the value of a, right? The value of a here. So the value of a is what's going to determine whether our parabola is going to open up or down. If a is positive, then our graph is going to open up. It's going to basically be an upward facing curve. And if a is negative, it's going to open down. So our parabola will open down. All parabolas have a vertical line that goes through their vertex called the axis of symmetry. So parabolas are symmetric about this line, meaning if you were to fold your parabola, if you were to fold the graph along the axis of symmetry, the right and left side would fold on top of each other, and they would land perfectly on top of each other. So the equation for our axis of symmetry is just the equation of a vertical line, and it's this equation here, x equals negative b over 2a. So we know that vertical lines have the equation of x equals some number, and since b and a are just real numbers, when we substitute them in, we're just going to get x equals some value here. And because the vertical line goes through our vertex, this value, this x value, is the x coordinate of our vertex. And then to find the y coordinate of our vertex, we would take this x value and evaluate our function f at that x value. So we have this equation in standard form, f of x equals 2x squared plus 8x plus 5. And we would like to find the vertex and the axis of symmetry for it. So to start, I usually like to establish the values of a, b, and c so that we can substitute all of those values into their corresponding places in our equations. So we know that the value of 2 here, that's a, 8 is b, and then 5 is c. Now they do take their signs that are in front of them, but in this case they're all positive. So to find the equation for the axis of symmetry, usually this is what you're going to do first, because then you use that value to find the vertex. We know that it's x equals the opposite of b over 2 times a. So it's going to be a vertical line. So we're going to substitute the values of b and a into this equation. So it's the opposite of 8 over 2 times 2, which is negative 8 over 4, which when you do this gives us negative 2. So x equals negative 2. That is the equation for our axis of symmetry. It's the vertical line that goes through the x value of negative 2. Now, what is our vertex? So this is the axis of symmetry. This right here is the axis of symmetry. So what is the vertex? So the vertex, we already know the x coordinate of our vertex. It's negative 2. And then to find the y coordinate of our vertex, we just take f and evaluate it at negative 2. We substitute negative 2 into our graph here. So we can go ahead and just do that now. So what is f of negative 2? So take negative 2 and substitute it in. We get 2 times negative 2 squared plus 8 times negative 2 plus 5. So negative 2 squared, that's 4. So this is equal to 2 times 4. 8 times negative 2, that's a negative 16. So minus 16 plus 5. This is 8. So 8, and then negative 16 plus 5 is negative 11. So 8 minus 11 is going to be negative 3. So f of negative 2 is negative 3. So this value gets substituted up here. So the vertex of this function lies at negative 2, negative 3. Again, which means the axis of symmetry is the vertical line x equals negative 2. So it passes through this point, and it's the point that our function is symmetric about.